equation is good for. So, as I told you, the cook, the chef, goes to the auction, fish auction, I'm sure there's another name, and suppose that there is a fish that weighs 1.7 kilos, okay? 1.7 kilos. And another one that weighs, I don't know, 3 kilos. How many portions can he get from these two pieces? So the chef goes with his calculator or his mobile phone and can quickly calculate by substituting these numbers. Okay, he can quickly calculate the portions that he can get. Just okay, making a substitution of 1.737 plus 2.385 times, and then the weight, 3 kilos. He says 8.8 portions. Okay, let me do it with a whole, to see, with the whole decimals, okay, of the linear feet. This is just 3 decimals with all the decimals, okay, so the calculator allows me to do it. So let me do it with all. 127. Okay, so it's the A plus B. This is the general equation, right? A plus bx. So y is our number of portions, okay? X is the mass in kilos, and A and B are these values, okay? This one is called the slope. Tells us how the weight, how the number of portions changes when you change the mass in kilos. And the intercept is called what's the weight when, you know, it doesn't make sense. When it weighs 0 kilos, how many portions? Just it's due to noise of the measurements, okay? Because they are realistic, not in the lab. They are real fish, not ideal. So 3 kilos, right? Yeah, it's the same. So 1.737 plus 2.381, that's enough with 3 decimal. That's what I was checking, if with 3 decimal is enough. So if I just substitute in the equation, how do you see it? Just this equation and substitute the mass in kilos by 3 kilos, it gives me 8.9 portions. So almost 9. So you say, okay, 9. I make a one little bit smaller and nobody will notice. And then so I can get 9 portions with a 3 kilo piece. I see that 3 kilos was not in the initial database, so we can't find it here. So if we get the least square minimization, we do this equation, we can know the number of portions, okay? It's very similar, right? It's very similar, yeah. But anyway, so yeah, it gives nearly the same value, but you didn't know before because the difference is 400 grams. 400 grams, and it gives you the same, almost the same portion, okay? So what if the mass is 1.7, another one? So here in the middle, how many portions? 5.7 portions. So that's close to, you know, not close to, close enough to 6. It's going to be 5, and then one which is 30% smaller. So it's sure that it can get 5 portions. 5 portions. So yeah, that's how it is. You know, they're realistic values. Let me get you another one, like 2.5. What happens with 2.5 kilos? See that there is no, you can know that if both with 1.7 and with 1.25, it gets the same number of portions, which is quite surprising. So with a mass of, let me get another one, 2.5 kilos. No, let me get another one. Yeah, 0.7 kilos. How many portions can we get? So the idea is the same. We substitute in the equation with 0.7 will give me 3.4 portions. Okay, 3.4 portions. So we're sure that we can get 3 portions. So without 0.5 we can get 2, and with 0.7, 3.4, which is nearly 3. So what's the value of what we're doing? With a simple equation, we don't have to carry a whole table with all the weights and see, but maybe the cook decides to do the table, yeah, but it wouldn't be a good idea. It's better to have this equation, so you can have to carry the equation, right? I'm thinking that, the cook, I'm being I'm criticizing, when I developed this example, it really seemed nice, right? It didn't seem nice, yeah, but being realistic now, I think that the cook would prefer to have a table, yes, a table with all the weights, 4.5, 4.6, 1, 1.2, yeah, on a table with all the possible values, or nearly, and then the number of portions, yes, but how could he get this table? He should have to measure all the possible weights of fish, and sometimes it would take like 1 year or 2 to get all the possible weights, and maybe some of them will never get. We will get like around 2 kilos a lot, but around 1.5 maybe 1 or 2, so or known. So how can we get with this equation allows us between 0.5 to 3.5 to get this table you want, to build it with only these 4 values, and it will be like 93.3 nearly high, more than 90% accurate. So how can we do this with only 4 points? Yeah, it's a bit risky, yeah, but the database should be larger, but it gives you a very good, quite good estimation. Using this equation, we could make a table, to say, okay, this is not practical, because today I'm sending my assistant, and my assistant does not know how to substitute an equation. Poor man, gets scared with I see an equation. How can we solve this? I can make an equation, I can make a table of any weight you can imagine of. Any weight, for instance. With only these 4 points. So I start with 0.5. So now I do 0.75, 1 kilo, 1 kilo, 100, 1, 2, 1, 250, 1, 3, 1, 4, 1, 5, any value, 1.7. How can we get all the number of portions that you can get? 1, 6,